Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 64. Minimum path sum. Given a m cross n grid filled with non-negative numbers, find a path from top left to bottom right, which minimizes the sum of all numbers along its path. Okay, and they have given the important thing: you can only move either down or right at any point in a time. Okay, so which means you cannot go to the top or you cannot go towards the left. Okay, you can either go to down or you can either go to right side. Okay, so this is what they have clearly stated in the problem statement. Fine. So see here, if this is the grid, then I can tell you the minimum path sum will be this highlighted path. Okay, you can also try with some other examples, some other path, but it won't give the minimized result. Can you understand this? So here the result will be 7. Okay. So how we are going to solve this? So the immediate thing that comes into my mind is greedy approach, right? Always whenever there is a minimum or maximum, we will be always subconsciously going with the greedy approach. And if the greedy approach fails, then only we want to go for all possible combinations. So what's going to be the greedy approach? So see here, initially, let me take black color. So initially I am at this point, right? Now what is my final state? I want to reach this. So this is going to be my final state, right? Okay. Now I can either go to right or I can either go to down. Okay. So I can either go to right or I can either go to down. Now which is minimum? Minimum is 1, right? So I'll be moving here. Again, which is minimum? Whether 5 or 4. 4 is minimum. Move here. Now which is minimum? Now I don't have anything in the bottom. So I obviously move towards the right side, right? So I'll be moving here. Again I'll be moving here. So how many times I moved? So sorry, what is the sum? What is the sum we got here in this greedy approach is 1 plus 1 plus 4 plus 2 plus 1. So which is equal to 7 plus 2 is equal to 9, right? But if I go with the path that they have given in the question, then it will be leading to a 7. It is leading to a 7. So 7 is a minimum path. So now hope you understand why we cannot do this using the greedy algorithm. So whenever greedy fails, where we are going? We are going to the recursion. We are going for a recursion for finding all possible combinations. So what is going to be the recursion function? So my recursion function. Now this recursion function will be having two varying parameters for this kind of question because they have clearly stated it is not a 1D array. It is not a 1D array. It is a 2D array or a matrix, right? So here we want two indices. One index represent the row and another index will represent the column. Okay, so let me take I and J. You can also take a row or column, that's your wish. Okay, now I am taking it as I and J. Okay, now whatsoever I have two possibilities, right? Two possibilities. So I can either go to right side. I can either go to right side. So if I want to go to right side, what does mean by it? It is, hey, keep the row as it is. Okay, only increase my column by 1. If I go to the down, hey, take the row and do plus 1 and keep the column as it is. So this is going to be your overall recursion. Okay, where you are going to start. So here we can do this in two ways. Okay, that's your wish. I will be openly giving that. So now I am going to use, like, this is the starting point and this is the ending point. Okay, if you want, you may take this as the end point and move towards left side and top and reach the start. So you can do this by two ways. Now I am going to teach you. We are going to take this as a start and this as the end. Okay, so this makes this problem simple to understand. Okay, once you can understand this, then you can go with anything. You can either take this as a start or this as a start. That's your wish. Okay, so now please, I will be explaining this. Just try to understand this. Okay, now let me take this again. Okay, now initially where should I start? So that's the first question arises, right? So initially I'll be starting from 0, 0. Okay, now from this 0, 0, wherever I can go, I can either go to the right side. If I go to the right side, then it will be like 0, 1, or go towards the down. So these are the two possibilities, right? Go towards the down. These are the two possibilities. Fine. Okay. Now the next thing, from this 0, 1, 0, 1 means here. Okay, from here, where I can go? I can either go to the right side, right? So if I go to the right side, it will be 0, 2, or you can go to down. Down means it is 1, 1. Again, here f of 1, 0 means here. From here, I can either go to right side. If I go to right side, it will be 1, 1, or I can go to down 2, 0. Hope you understand up to this. Now 0, 2. 0, 2 means here 0, 2. Okay, from here I can either go to right side or I can go to down, right? If I go to right side, it will be f of, let me just draw like this, f of 0, 3, or else I can go to f of 1, 2. 1, 2 means here. Okay. Now again for 1, 1, from here where I can go to right side. If I go to right side, it will be 1, 2, or it will be 2, 1. Similarly for this 1, 1 also, it will be f of 1, 2 or f of 2, 1. Similarly for 2, 0. 2, 0 means here. From here I can either go to right side or down, right? So if I go to right side, it will be f of 2, 1, or else it will be 3, 0. Now just listen this. Here comes one of the base condition. Just observe. See here, f of 0, 3. 0, 3 means where? It is something particularly here. So there is nothing. So what is my base condition? If my column or row exceeds the value, then there itself I'll be returning what? I'll be returning, hey, this is not the minimum path. This is going to the maximum path. I'll be returning like, hey, from this you cannot reach the destination. So I'll be returning the infinity. Or int max, anything. So infinity. Okay, I'll be telling you why we are returning infinity when I am completing this entirely. Okay. Now come up with me. Now 1, 2. 1, 2 means I am particularly here, right? 1, 2. Yes. Now from here I can either go to right side. If I go to right side, it will be f of 1, 3, or I can go to down 2, 2. Okay. Now for this 1, 2, here also I can either go to f of 1, 3, or I can go to f of 2, 2. From 2, 1 means here. Okay, from here I can either go to right side. If I go to right side, it will be 2, 2, or I can go to down 3, 1. Okay, similarly we are going to find these things also. Now let me finish these things so that you can understand this clearly. Now again 1, 3, this will be returning infinity. Okay, and 2, 2. So 2, 2 is going to be our result. 2, 2 is going to be our destination. So from here, what I am going to return? Return the value at the 2, 2. What is the value of 2, 2? It is 1. So return 1. Okay. Similarly, from this 1, 3, I will be returning infinity. Meanwhile, in this 2, 2, I will be returning 1. Here also 2, 2, return 1. Here I will be returning infinity. So similarly, just complete these right recursion calls by yourself. I will be just completing this left recursion call. Okay. Just fine. Just understand this. Next. In next step, see here infinity, here 1, which is minimum. 1 is minimum. So from here, what it will be returning is 1 plus what is 1, 2. 1, 2 means it is something here. So 1. So 1 plus 1. The function calls value will be minimum among this infinity and this 1, and I'll be taking this f of 1, 2's value also. So 1 plus 1 is equal to 2. So it will be returning 2. From here 0, 2, which will be taking whether infinity or 2. 2 is minimum. Take 2. Okay. Now what is 0, 2? 0, 2 means something like here. Okay. So what is the value? It is 1. So plus 1. Okay. Similarly here also it will be 1 plus what is 1, 2? 1, 2 means this 1 only, right? So again here also 1, 1, which is equal to 2. Okay. Similarly here 2, 1. 2, 1 means something like 2, 1 here, right? 2, 1. So it will be 2. 2 plus what is the minimum among them? It is 1. So it will be returning 3. It will be returning 3. Now which is minimum among them? 2 is minimum. 2 plus 1 comma 1. 1 comma 1 means is 5. So 2 plus 5 is equal to 7. So here it will be returning 7. From here it will be returning 3. Which is minimum? 3 is minimum. 3 is minimum. So take 3 plus what is 0 comma 1? 0 comma 1 is 3. 0 comma 1 is 3. So I'll be taking 3 again. Okay. Now I'll be returning this value. So 6. Okay. From this right side, absolutely it will be returning a greater value than this 6, or it will be equal to this 6. Okay. After solving this, you can understand this. Just go and solve these recursion calls by yourself, or let me try this also. It is not a big deal. Okay. But the video goes lengthy. Okay. So let me just try this. If you can try this and you can get a result, then try by yourself, or else you can just watch it. Okay, just skip this part if you want. Okay, now from here, if I go to the right side, it will be f of 1 comma 3. From here, if I go to down, it will be f of 2 comma 2. From here, if I go to right side, it will be 2 comma 2. From here, if I go to down, it will be 3 comma 1. From here, if I go to again 2 comma 2, here 3 comma 1, here it will be not going down, it will be directly returning what? Infinity, because here comes 3. Okay, similarly here from this point it will be returning what is 2 comma 2? It is 1, right? From this point it will be returning 1, but from this 1 comma 3, it will be returning infinity. So which is minimum? 1 is minimum. So 1 plus. Okay, what is 1 comma 2? 1 comma 2 means 2. 1 comma 2 means 1 comma 2 means this 1. So 1 plus 1, which is equal to 2 here. So this 2 comma 2 will be returning 1, and this 3 comma 1 is returning infinity. So among this 1 is minimum, plus what is 2 comma 1? 2 comma 1 is 2. 2 comma 1 is 2. So 2. So here it returns 3. From here it is returning 2. Now which is minimum? 2 is minimum. 2 plus what is f of 1 comma 1? 1 comma 1 is 5. Okay. 2 plus 5, which is equal to 7. So from here it will be returning 7, and from here let me compute. So 2 comma 2 means it will be returning 1. 3 comma 1 means it will be returning infinity because of this 3. Okay. Now here comes 1 plus what is 2 comma 1? 2 comma 1 is 2. So okay. So 2, which means it will be returning 3. So 3 or infinity, 3 is minimum. 3 plus what is 2 comma 0? 2 comma 0. 2 comma 0 is 4. 2 comma 0 is 4. So 4, which is equal to 7. So here also 7, there also 7. So 7 is the minimum. 7 is the minimum possible value. 7 plus what is 1 comma 0? So 1 comma 0 is 1. So plus 1, which is equal to 8. So from here it is returning 8. From there it is returning 6, which is minimum. 6 is minimum. So from here it will be having 6 plus what is 0 comma 0? 0 comma 0 is 1. 6 plus 1, which is equal to 7. So 7 is our required output. Can you understand this? So this is how we will be solving this entirely. So what is the trick is, we want to just divide the main problem into a sub problem. Okay, like I am having a main problem like I want to start from 0 comma 0, and I am just dividing into a sub problem like either you can go to the right side or you can go to the bottom. So there is a subdivision. So among that I will be taking the minimum and take myself as one of the path member and return it. That's it. So this is how we want to implement the recursion. Okay, fine. Now tell me what is going to be the time complexity. So this is going to be much more important. So what is going to be the time complexity? So the time complexity will be O of up to 2 power m into n. Okay, almost in the worst case. And also space complexity will be O of n cross m. So this is the time and space complexity. Why the time complexity is 2 power m cross n? Because for every recursion we have 2 recursion calls. So for m cross n recursion we have absolutely 2 power m cross n. So that's the worst condition. And space complexity is of n cross m because here m. So m represent the row and n represent the column. Okay. Now why it is because see here, this entire thing will be done using the recursion stack, auxiliary stack space. If you already saw my recursion introduction, then you can understand this, right? So because of that only we are having a space complexity like this. Okay, now let's see the code. So see here I have written the Java code. If you want C++ or Python code, just go and search in the description. Okay, so see here, first of all I'll be taking the m and n value, and I'll be returning the answer that is written by the path function. Okay, now path function, what it is going to do, here we are just giving 0,0 as the input, as the argument is passed, and here the parameter will be I and j. Okay, rest of them are non-varying parameter, which means they will be remaining as it is, but meanwhile these two will be changing accordingly. Right, now what are two base conditions? Two base conditions are, if my row and column are apart from my indices, then I'll be returning max value, which means infinity. Okay, keep that in mind. Okay, now if I reach the destination, which means the last row, last column, then I'll be returning its value. That's it. Okay, now what are two recursion calls I am going to do? What are two sub problems I am going to divide this main problem? One is I want to go to right side. Okay, so instead of giving this line here, you can also take the right as this and down as this, and you can take the minimum among right and down, then do plus grid of I and j. That's also fine, and this is also fine. Okay, so what I'm doing in right, hey, go to my right side, which means column plus 1. If it is down, hey, go to the down, which means a row plus 1, and take myself as one of the path member and return which is minimum. Okay, because they have clearly stated, just return which is minimum. If it is maximum, don't worry, put a max. That's it. Can you understand this? Always remember, whenever we are doing one problem, we want to study much more cases. So if it is maximum, then instead of minimum keyword, I'll be using maximum. That's it. Can you understand this? Now if I submit it, it won't be submitted successfully, because here m and n will be 200. In our worst condition, it will be going for 2 power 400, which is exceeding 10 power 9. That is a clock time for a running time, right? Okay, now we want to optimize it. Okay, how we are going to optimize it? So we are going to the next approach called memoization. Let me take this. It will be helpful when we are converting into a memoization. So memoization is very easy. We can do the memoization in two ways. One is using the hash map or using the array. Okay, now I am going to show you using the array only. Okay, by seeing that array approach, you can able to implement the hash map approach. Okay, so the second thing is memoization. Okay, what is memoization? So see here, see in this example, here it is f of 1, 1, and similarly here also it is f of 1, 1. Okay, always the recursion is a DFS approach. Which means it goes apart from the depth. It goes towards the depth, then only it will be returning. For example, it will be going towards this, then only it will be returning, towards this, then only returning, towards this. After finishing this left subtree only, it will be going to the right subtree itself. Keep that in the mind. Okay, it finishes one recursion call completely, then only it will be moving to the next recursion call. So that is called the depth first traversal, right? So similarly here also, once I found out this f of 1, 1's answer, if I found out the f of 1, 1's answer, then I'll be storing, hey, f of 1, 1 means I'll be returning 7 in my memory. When it again occurs here, instead of going and find outing all these stuffs, I'll be simply returning, hey, already I saw this and computed this, why should I again go? I'll be just taking from that and I'll be returning it the 7. Can you understand this? So this is going to be the memoization. Okay, there are few steps to do the memoization. The first thing is we want to construct the array. Or matrix using the variable parameters. So here, what are the varying parameters? So these two are the varying parameters. Okay, so take these two things. What will be its range? Its range will be from 0 up to m minus 1, and here also 0 up to n minus 1. So my matrix will be something looks like m cross n, m cross n. For example, if it is m cross n, the given matrix, the given input matrix is 3 cross 3, right? Yes, 3 cross 3. Then now my matrix something looks like 3 cross 3 matrix. My matrix looks like 3 cross 3 matrix, and I want to initialize the value. Like that value should not be any return value of the any recursion call. See here every recursion call will be returning infinity or 1 or 2, any positive numbers. In question itself they have clearly stated there is non-negative numbers. So here I'll be making everything as negative numbers, or you can also put a null if you wish. Here I will be putting -1. Okay, you can also put -2, but always remember every value should be same. Okay, you cannot put like everything as -1 and here as -2. Okay, you cannot put like that. Always remember, put everything as any value that will be not returned by any functionalities. Okay, by any recursion call. Okay, now what is the next step? Second step is I want to add 2 more lines. One line is here in this base condition. In this base condition, just add if or take for example it is let us take this as dp. Okay, this variable, this matrix is dp. Now if my dp of I and j is not equal to -1, then I can tell you I already computed them, so I'll be returning dp of I and j. That's it. Okay, and then before returning I want to add one more condition, one more statement, like dp of I and j is equal to minimum of right and down. Then return the dp of I and j, which means I storing here I am storing. Okay, here I am checking whether it is computed already, and returning it. So these are the 2 things I want to add here, such that now our entire code is memoized and optimized. Now guess what is the time complexity? So the time complexity will be over m cross n. It is way optimized, right? From the exponential to up to a linear time, or it is a polynomial. I don't know how to tell this, but it is like a n square, So can you understand how far we have optimized this? Okay, so what is the space complexity? It will be m cross n. That's it. So this is going to be the time and space complexity analysis. Okay, got it? So let us finish this, then we can go to the next optimization. So just come up with this. So this is going to be your memoization code. Okay, so see here. First of all, everything is similar. Here I am initializing the matrix and filling everything as -1 initially. Okay. Stay there. So see here everything is similar. I am adding only one base condition, and here also everything is similar. After, when I am returning it, I will be storing in the dp array or matrix, then only I will be returning it. I understand this. So by doing this, we will be submitting this problem successfully, this solution successfully. But when you are attending in TCS Code Vita or some other interview kind of process, that they will be telling you to optimize the space in your real-time technical round. Okay, in technical HR, they will be asking you to optimize further. In that time, you want to know how we are going to optimize this further. If we are using the hash map for the memoization, then we cannot optimize further. That's the reason why I am just telling you always do with the help of the array or matrix. If you don't have time, or you are doing in a hurry, then do it in a hash map. Okay, unless or until that, always use the array or matrix, so that it will be helpful when you are doing a optimization. So let me take this. So the next thing is tabulation, right? Now what is meant by tabulation? So let me paste here. So tabulation. So in simple words, if I want to tell you about the tabulation, it is like, what are the two factors that are affecting this space? They are, one is recursion stack, the auxiliary stack we used. Another one is, we are using a matrix, right? Okay, First, I want to eliminate this recursion stack. Okay. So how we can eliminate the recursion stack? I don't want to use the recursion itself. Can I understand this? I don't want to use the recursion itself. So if it is not using the recursion, then I am going to use the looping. Then I want to use the looping. Okay, fine. So here also there are some simple steps so that you can just convert a memorization code into a tabulation. So observe this carefully because tabulation is way harder than you think. Okay. So see here. First of all, what is a matrix? As of now, I have a matrix of size 3 cross 3. So let me draw this. So this is what the matrix I have. Okay, initially here. Okay. Now always see the base condition. So what is the base condition here? The base condition is I is equal to m or j is equal to n. Then I want to return the maximum value. So for example, the input array is 3 cross 3. Then only this will be the matrix, right? This will be the DP matrix. Okay. Now understand this clearly. We want the row index which is equal to m and column index which is equal to n. Which means we also want one more column, one more row. Can you understand what I am saying? Okay. So this is going to be 3 and this is going to be 3. Okay. Whenever this arises, what should I return? I should return infinity. So mark everything as infinity. And infinity. Fine. Just come up with me. Next base condition is I is equal to m minus 1 and j is equal to n minus 1, which means 2, 2 will be what? Return the grid of I, j. So here, what is 2, 2? It is 1. So here we want to initialize it as 1. Apart from that, every else will be you can take 0 if you want, or you can take -1 you want, anything you want, because here we are not going to compute anything with the DP of I and j. We are just assigning some value into it. That's the reason why you can take anything here. Okay, that's yours. Okay, I'll be taking simply 0. You can take anything, or don't initialize anything there. That's yours. Okay. Now always skip this line. Okay. Now these two lines are going to be the body of the recursion, right? Body of the recursion, and this is going to be the return value. So these 3 lines are going to be the body of the recursion. Okay. So now put a for loop. Whenever there is a body, then you want to put a for loop. Okay. Now for loop. Now I will be from range of where to where. Here the range of I will be starting from 0 up to where? Up to I will be going up to m minus 1, right? So here also similarly, I want to start my I from m minus 1 up to 0. Ulta, reverse. Okay. So here in recursion, we have started from 0 up to m minus 1. But here in your tabulation, we will be always starting from m minus 1 to 0. If there is 0 to m minus 1, here m minus 1 to 0. If there is m minus 1 to 0, then here it will be 0 to m minus 1. Always reverse. Okay. Now the next thing, for j will be from n minus 1 up to 0. You can straight away see here, right? Now what is the base condition here? It is m minus 1 and n minus 1. Then I want to return it. So here I want to skip it. So this is the step many of them will be doing a mistake. Even I did a mistake. Okay. So here what I'm going to do is if my I is equal to m minus 1 or my j is equal to n minus 1, then I want to do what? Sorry, and so this implies what? Destination, but destination is already initialized here, right? So don't do anything, right? Just continue. Don't do anything. Just continue. Apart from that, what should I do? So here right is equal to what is done here? Grid of I plus j. Sorry, grid of I and j. Plus what is here? Path is what? The recursion call. Instead of the recursion call, to dp. What is the varying parameter? I and j plus 1. To I j plus 1. Similarly, down is equal to grid of I j plus dp of here I plus 1 and j. Similarly, I plus 1 j. Simple, simple. After everything, after this for loop, I'll be just returning return. What is the value I have returned here? I have returned the value of path of 0, 0. So here also, what should I return? dp of 0, 0. That's it. Can you understand this? So this is how we will be changing our memorization code into a tabulation code. Now, what is the time complexity? It will be n cross m, similar to it. But space complexity will be also m cross n. But here it will be only because of the array we have taken. Okay, because not because of the recursion stack. So we have eliminated the recursion stack, right? So let me just comment this out and let me show the tabulation code. See here, this is going to be a tabulation code. See here. So everything is similar. Here I have added m plus 1 and n plus 1. I already told you because of the base condition. In base condition, we need n and m. That's the reason why here also we need n as a index and m as a index. That's the reason why I put here right like this. And then now here I want to fill everything that is equal to n or that is equal to m as infinity. That's the reason why here also I filled everything as infinity. That border, the top, down and the right side is infinity. That's the reason why I filled here also. Now the last index, the m minus 1 and n minus 1 index will be equal to grid of m minus 1 and n minus 1. Okay. Now I'm using a 2 for loops, and inside that, so this line is going to be much more important because many of them will be leaving a mistake here. So that this line, if this line is erased, then all the values will becomes infinity. Okay, so please don't do a mistake here. Okay, now rest of them are I written in the drawing explanation. Okay, so this is going to be your tabulation code. So now from this tabulation code, we are going to check whether we can still optimize our space because we are only eliminate the recursion stack. We are not fully optimized our space, right? So now my aim is going to be eliminating my space, whether if the space is O of 1 or O of m or O of n whatsoever, but I want to check whether I can eliminate still anything in the space. Okay, so this is going to be the space optimization. So for space optimization, we want to check whether we can eliminate or not. Okay, how we are going to check it? So observe this carefully, listen this carefully, see here. So here in this body, I want dp of I and j plus 1, okay, and dp of I plus 1 and j and dp of I and j. So from here I can tell you for this loop, I only need dp of I and dp of I plus 1. That's it. Two things, which means for 3 cross 3 matrix as an input, we only want 3 columns, but only 2 rows. Only 2 rows is enough, right? Which means this represent I. Yes, so this represent I plus 1. That's it. Can you understand this? We only want I and I plus 1. Yes. So why should I want to take entire matrix? For example, if this matrix is something like 10 rows, meanwhile there is only 3 columns, then also I will be taking only this amount. Okay, I will be taking 3 rows and 2 rows and the column they have given in the input. If in the input they have given like 100 cross 10, then I will be taking here as 10 columns. Meanwhile, there is only 2 rows. So by using this, we can say we can obviously space optimize it up to what? Up to O of column as a space complexity. Now hope you understand this clearly. Yes. Okay. Now let me just teach you this. Fine. So how we are going to do this? Initially whatever everything will be looks like. So instead of this line, we have replaced like this. Okay, fine. Now instead of this, what I should be replacing here? That's going to be the next condition, right? So for 3 cross 3, we need 2 rows. Meanwhile, 4 columns because of the base condition we have added. For that reason only we have here as n plus 1, right? So here comes 2 cross 4. Okay. So 0, 1, 2, 3. Here comes 0 and 1. Fine, fine. Just listen here. So initially, what my entire this one in this will be going to be is infinity, 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 and infinity. Similarly, here the third index of the 0th row will be infinity, infinity. Now anything else will be here 0, here 0, but here comes if we are going to take this matrix, then what is the final value? It is 1, right? So I'll be initializing here as 1. That's it. Okay. Now come up with me. So this is over. This is like we want to initialize at the dp of 0 and 2. That's it. Okay. Now these for loops will be same. And this continue is also same. And here comes the body. In the body, we want to do like right is equal to grid of I and j plus dp of, see here, whenever there arises a 0, whenever there is arises as I, okay, we want to put as 0. And here comes j plus 1. Okay, similarly d is equal to grid plus dp of, here comes what, I plus 1. So it will be 1. And j plus 1. Sorry, j. Okay. Now here dp of I and j, right? So here comes dp of, instead of I want to use what? 0. Instead of j, I will be using j itself. Okay, which is equal to min of right and down. At last, what should I return? I will be returning dp of 0, 0. That's it. Similarly, can I understand this? What we are going to do? Okay. Now I forgot to add 2 lines. See here. After doing this in a body, we want to swap it. Right? So how I am going to swap it? See here. dp of this 0th index. The 0th index will be occupying my, dp of my first index will be occupying like dp of 0. Can you understand this? Now see here, these two things result will be stored in my 0th index. Now for my next iteration, the 0th index value will be stored in the first index, so that again my result will be storing in the 0th index. Okay, again I'll be doing a swap. So it is like instead of taking entire matrix, I'll be taking only 2 rows, such that whenever we are going up, I'll be swapping them, such that I'll be getting these lines. Okay. Now at last just return dp of 0 and 0. That's it. So now tell me, what is the time complexity? So time complexity will be m cross n, but space complexity will be over n columns. Okay, columns, number of columns. So this is what the time and space complexity. You may ask, hey, we have taken 2 cross column plus 1. So this is the dimension of the matrix. Then how come the space complexity is like that? See here, 2 is a constant. Can I understand this? We can take instead of taking this as dp, you can also take current and previous. That's your wish. Okay, I'll be showing that in the code. Okay, now my kind request is, please, by using this code, dry run yourself by using any example, so that you can understand this space optimization clearly. Okay, now let us see the code. So see here, this is going to be the space optimization code. Everything is similar. Okay, everything is similar except previous. Here I am taking the previous as n plus 1. Okay, and filling everything as a infinity. So this is going to be the dp of 1. In my explanation, this is going to be dp of 1. Previous is going to be dp of 1. Okay, now so this is the current, where you can either fill everything with the maximum value, or you can leave this line also. That's your wish. But here it will be compulsory. So you want to take this as a last grid, the last row, last column value. So this is going to be dp of 0. Okay, now can you relate? We can also do this using two variables, or we can do this using 2 cross column plus 1 matrix also. So see here comes the for loop and the continue statement also similar to it, but here in these in these 3 lines we are going to change. How? See here, first of all here instead of dp of I changed into current. Instead of dp of I plus 1, I changed into previous. Here also similarly, instead of dp of I changed into current. Can you understand this? At last, I will be just changing my previous into current value, and at last I will be returning the current of 0. Or if you are doing in a matrix, then you will be returning dp of 0 comma 0, like here. See here, current is equivalent to what? dp of 0. So here, instead of current, if you use the dp of 0, then it will be dp of 0 comma 0. That's it. So the space optimization will be understood once you can dry run this code by yourself. Okay, and this will be more important when you are going for a technical HR round. Okay, then that they will be asking you to optimize this further, and you will be ending up in the space optimization technique. Fine. So if you really like this video and subscribe to my channel, and don't skip any videos in the DP series, because DP series is much more important and hard to understand. If you have any doubts, okay, then you can freely comment it out. I'll be commenting the answers. And if you have any suggestion, or if you want me to teach any other problems, just comment below. I'll be posting those videos. Thank you.